Hi guys, in the previous video lesson we covered up co-function identities that help us solve trigonometric questions. In this video lesson we will learn about compound angle formulas. Now we can see compound angle formulas are these formulas in which when we have to find out a trigonometric ratio for an angle that has been split up into two parts, then we can even split their trigonometric ratios like this. For example, if I have to write down sine of angle A plus B, I can write it as sine of A cos of B plus cos A sine B. So instead of adding the angles and write it as one angle, I can split this up using compound angle formula. So let's understand this with an example. If I have to find out what is sine 30 degrees plus 45 degrees, so instead of going this way, that I put sine 75 and put it on the calculator, this is one way of solving it. Instead of solving this way, if I'm asked to use compound angle formula, I will be writing this as sine 30 plus 45 equal to sine 30 cos 45 plus cos 30 sine 45. As I know, sine 30 is 1 by 2 times cos 45 is 1 by root 2, cos 30 is root 3 by 2, and sine 45 is 1 by root 2. We just have to multiply it and see what we get. Add this up, multiply this by this. I have the same denominators. All I have to do is just add my numerators. So it gives me 1 plus root 3 over 2 root 2. If you want to rationalize, you can rationalize it further. And how would that look like? 1 plus root 3 divided by 2 root 2. I multiply by root 2 and denominator also by root 2. I just have to use distributive property on this and I get root 2 plus root 3 times root 2 is root 6 over root 2 times root 2 is 2. So this 2 comes from here. Root 2 times root 2 is this 2. So I get root 2 plus root 6 over 4. And this is how I leave my final answer as if I'm required to rationalize it. Similarly, we can use other formulas too. If we are given two angles as a difference, then we can apply this formula, sine A cos B minus cos A sine B. If we are asked to find out the cosine ratio of two angles with a plus sign, then we use cos A cos B minus sine A sine B, and so on. So this is how we basically use these formulas. These formulas are supposed to be learned depending upon school to school. Let's do more problems related to compound angle formula. If we have to rewrite each expression as a single trigonometric ratio and then evaluate the ratio, let's say the question is tan 170 minus tan 110 degrees over 1 plus tan 170 times tan 110. Now we would go back and check what formula does it represent like, and we see here it's like this. It's tan 170 minus tan 110, so it represents tan A minus B, compound angle formula. So we write it as tan A minus B. A is 170 degrees, B is 110 degrees. So we write it as tan 170 minus 110 degrees, which is equal to tan 60 degrees. And the value is root 3. So they wanted us to write it as a single trigonometric ratio, that is tan 60, and then evaluate, and this is the value. Let's do another question where we have cosine 5 pi by 12 times cosine pi by 12 plus sine 5 pi by 12 times sine pi by 12. Now we have cosine, so this looks like cosine A cosine B, because these two angles are different. This is 5 pi by 12, this is pi by 12, plus sine A, because 5 pi by 12, same 5 pi by 12 here we see, times sine B, pi by 12, pi by 12. So this is nothing but, when we check here, is cosine A times cosine B plus sine A sine B, can be written as cosine A minus B. So we write it as cosine A minus B. That means this whole equation can be written as cosine A is 5 pi by 12 minus pi by 12. Now let's solve this here. Cosine 5 pi by 12 minus pi by 12 can be written as cosine because this is the same denominator. 4 pi by 12. Bring it down to lowest terms, we get cosine pi by 3, and the value of cosine pi by 3 from similar triangles we get is 1 over 2. This is how we use compound angle formulas when we are given the expanded form of the formula. So this is the expanded form of the formula, and we write it down as 1 trigonometric ratio of the formula. Let's do another problem. Let's read the question. The question says, use the appropriate compound angle formula to determine the exact value of each expression. And your expression is given to you as cosine 15 degrees. Now, if you're given cosine 15 degrees and we are supposed to use compound angle formula, so our first goal is to actually split this angle up into two angles. You need not split them up into equal angles. They have to be different angles. But you need to make sure that the angles that you split them up into should lie on your special triangles. And we see that 15 can be written as a difference of 45 and 30. Both 45 and 30 lie on your special triangles. Now this looks like cosine A minus B, and we know cosine A minus B is nothing but cos A cos B plus sine A sine B. So we write it as cos 45 times cos 30 plus sine 45 times sine 30. Cos 45 is 1 by root 2. Cos 30 is root 3 by 2. Sine 45 is 1 by root 2. Sine 30 is 1 by 2. When we solve this, we get root 3 over 2 root 2. And we solve this, we get 1 over 2 root 2. And this is what we get. If we rationalize it, we would get root 4 plus root 6 over 4. Let's take up another example. And the question says, find tan. And the question asks you to solve tan 5 pi by 12 using compound angle formula. Now, in order to split this up into two angles, we have to first convert this to degrees. But that work has to be on your rough side. So, for example, I do here 5 pi by 12. I divide by pi and I multiply by 180 degrees. That's the way how we convert pi to degrees. Pi gets cancelled. We get, so 15 times 5 is 75. This is what we finally get. Now we think, how can we split this 75 such that we are able to get two angles that lie on the special triangle? And we see that the angles are 45 and 30 degrees. Now when we have to write down here the answer, we do not have to write it down in degrees because the question is not given in degrees. Question is given in radians. So how do we have to show the splitting here is, we know 45 degrees is nothing but pi by 4 that we have already learned from the previous unit plus pi by 6. Now this represents tan A plus B, and let's go back and check how tan A plus B is split up. So we see tan A plus B can be written as tan A plus tan B over 1 minus tan A tan B. That's how we can write this down. Tan A plus tan B over 1 minus tan A times tan B. So when we look at our special triangles, tan pi by 4 is technically tan 45. Value is 1. This is tan pi by 6 is 1 over root 3. 1 minus tan pi by 4 is 1 times, this is multiplication, tan pi by 6 is 1 over root 3 again. And all we have to do is just make the denominators common because we are adding here. So if we make the denominators common, we multiply by root 3 both numerator and denominator. We get root 3 by root 3 plus 1 by root 3 over, this is 1 minus 1 by root 3. Again, we do the same thing, make the denominators common, multiply the numerator and denominator with root 3. We get root 3 plus 1 over root 3 as a numerator. And then we get root 3 minus 1 over root 3. Similar denominators get cancelled out. Ultimately, we're left with root 3 plus 1 over root 3 minus 1. Can be written as root 3 plus 1 over root 3 minus 1. If you want to rationalize it, you just have to multiply it by the conjugate of it. This is root 3 plus 1 square over root 3 square minus 1. That gives you root 3 plus 1 square over 3 minus 1, which is the same numerator divided by 2. So here when the question asks you to use the appropriate compound angle formula to create an equivalent expression, We do not have to find the value. All we have to do is just leave it as an expression. For example, if we have sine pi plus x, we know this looks like sine a plus b, and sine a plus b is written as sine a cos b plus sine b cos a. So that is what we're going to be doing here is, this is a, this is b. We write it as sine pi cos x plus sine x cos pi. Sine pi we get is 0 times cos x. Sine x written as is, cos pi is minus 1. 0 times cos x is 0. 1 times, remember this is not sine x minus 1. This means multiplication. So we are multiplying sine x with minus 1. So we get minus sine x. Final answer is negative sine x.